This video is just going to be a brief recap of how to solve inequalities, and we're also going to look at how to put our answers in set notation, which is going to carry over from our work with equations in Unit 2A. So one of the most important things to remember when we solve inequalities is that we flip the sign anytime we multiply or divide by a -1, or by a negative number in general. So if we look at this example, we know that 2 is greater than 1. So if I were to set 2 and 1 on a seesaw here, 2 is greater, so it's going to balance down. But if I multiply both sides of that seesaw by -1, now my balance is shifted. Even though 2 is a larger number, when we make it negative, it's further away from 0, so its value is actually less than that of -1. In order to correct the balance, we have to flip the inequality symbol around to reflect this change. And that's why anytime we multiply or divide on both sides of an inequality by a negative number, we have to flip the sign in the middle. So, remember that we solve inequalities the same way as we solve equations. So I look for my variable, I think about what I need to do to isolate that variable. So here I'm going to multiply by 6 on both sides. And we'll get x is greater than or equal to -42. I multiplied by +6, so my sign stays the same for my inequality. Now, for set notation, we start with our inequality. And we're defining the values of x such that x is greater than or equal to -42. So it's very similar to what we did before with equations. We have the x, we have the divider, and then we have our rule. Next, we want to circle possible solutions. So my answer said that x is greater than or equal to -42, so I want to circle any numbers that works for. So -120 and -43 are not greater than or equal to -42, but 7, -41, and 43 are all greater. Because we have the or equal to, we can also include the -42. If we look at the next one, we have -4 times k is greater than 16. So in order to isolate k, I'm going to divide by -4. And because I divided by a negative, I know that I have to flip my inequality symbol around. So we have -4 on the right-hand side and k on the left-hand side. So our set notation is going to be the values of k such that k is less than -4. And now we circle any possible solutions. -10 is less than -4, -6 is. Because it's strictly less than, -4 is not a possible solution. We can't say that -4 is less than -4 because they're the same value, so that doesn't work. And then obviously all of these numbers down here are greater. If we look at our last example here, we have 3 minus x is greater than or equal to 8. So my first step, I'm going to move that 3 over. So we have x is greater than or equal to 5. And now we have -x is greater than or equal to 5. So I'm going to divide both sides by -1. And when we do that, we have to flip our inequality symbol around. So we end up with x is less than or equal to -5. And in our set notation, we have x such that x is less than or equal to -5. And then we want to select all of our possible solutions. So -10 and -6 are both less than -5. And because we have the or equal to, we can select -5 as well.